So what we're going to do is we're going to convert some of these expressions into some power series expressions so that we can actually easily integrate and differentiate these. So this is a non-elementary integral, although we do have an integral that we can deal with this with. We're going to just convert it into a non-elementary integral. So what we're going to say is this, that f of x, okay, so this 1 over 1 minus x function is really a very useful one because we do all sorts of substitutions and manipulations to it to be able to generate new functions, because the sigma form of this is very simple. It's just going to be x squared, and we can do when we do the substitution here becomes fairly straightforward. So this is one that we want to be able to use. So notice that in here, to get the 1 over 1 plus 4x squared, we're just replacing that x, the original x, with a minus 4x squared, and we generate that 1 plus 4x squared. So we're just going to say then that the f of x is going to be 1 over 1 plus 4x squared, and that's going to be generated with this function here. So when we substitute the negative 4x squared in there, so notice that there's my substitution. There's my substitution into the series function. So I took that, I put it into there. Okay, so my series function in sigma notation looks like this: n equals 0 to infinity, and this is going to be, I'm going to maybe, well, we'll just leave it like that. No, I'm going to maybe write it like this: negative 1, because we know it's alternating, and that's going to be 16 and x to the power 2n. Okay, so make sure that's a little bit more clear, 2n. Alright, so there's our f of x function, and we want to integrate this to get the big F. So basically the big F function is going to be the integral of that function. Okay, so there's our integral. Okay, if this integral is the one we want, we can alternatively integrate then the sigma notation form of it. Okay, so there's our integral form in the sigma. There's our integral in the sigma notation form. So then, since this is just a power, this becomes easy to integrate. And this is why we like to integrate and differentiate power series. Okay, so that negative 1 is a constant. Okay, so it stays the same. 16 is a constant. We're going to use a power rule on the x part of this. So it becomes x to the 2n plus 1 over 2n plus 1, and then plus c. So there it is. There is our series function that represents the integral of that non-elementary